A pencil looks simple enough to ignore. Snap it in half and you see wood wrapped around a dark core, nothing more. But that neat cross-section hides a tightly controlled manufacturing process where each stage has been refined over decades. Every clean line a pencil produces depends on decisions made long before it reaches your hand. It starts in a forest, not a factory. The preferred material is incense cedar, a wood chosen for its straight grain, low density, and ability to sharpen without splintering. When a tree is cut, it is not immediately turned into pencils. The logs are transported to a mill and cut into shorter sections, then fed into saws that slice them into thin boards. These boards are further processed into slats, each about 185 millimeters long, 75 millimeters wide, and roughly 5 millimeters thick. Those dimensions are not arbitrary. They are designed to fit standard pencil lengths and allow multiple pencils to be produced from a single slat. Freshly cut wood holds a surprising amount of moisture, sometimes over 20% by weight. If that moisture remains, the wood will warp or crack as it dries later, ruining the final product. So the slats are stacked and placed in drying kilns. Warm air circulates through the stacks, slowly reducing moisture content to around 6 to 8%. This step has to be controlled carefully. Dry too fast and the wood can develop internal stresses. Dry too slowly and production slows down. Timing, temperature, and airflow all matter. Once dried, the slats move to planing machines that shave their surfaces until they are smooth and perfectly uniform. Even small variations in thickness can cause problems later when slats are glued together. After planing, each slat is passed through a grooving machine. This machine uses rotating cutters to carve long parallel channels along the length of the wood. A typical slat will have 8 or 9 grooves, each about 2 millimeters deep. These grooves are where the graphite cores will sit. At this stage, the wood looks like a series of shallow tracks carved into a flat board. There is still no sign of a pencil, just preparation. Meanwhile, in another part of the factory, the core material is being made. The core is often called lead, but it contains no lead at all. It is a mixture of graphite and clay. Graphite is a crystalline form of carbon, and its structure allows layers to slide over each other easily. Clay, on the other hand, acts as a binder and controls hardness. The ratio between graphite and clay determines the grade of the pencil. A soft 2B pencil might contain around 70% graphite and 30% clay. A hard 4H pencil might reverse that balance. The raw graphite arrives as chunks or powder and is ground into a fine consistency. Clay is also refined into a smooth powder. These materials are then mixed with water to form a thick paste. The texture at this stage is similar to wet ceramic clay. It needs to be uniform with no lumps, because any inconsistency could weaken the final core. This paste is fed into an extruder. The extruder forces the material through a small opening, shaping it into long, thin rods. These rods emerge continuously, like strands of spaghetti, and are cut into lengths slightly shorter than the wooden slats. They are fragile at this point and must be handled carefully. Drying comes next. The rods are placed on trays and left to dry until they hold their shape without deformation, but they are still not strong enough for use. To achieve the necessary hardness, they are fired in a kiln at temperatures ranging from about 800 to 1,000 degrees Celsius. This firing process drives off remaining moisture and causes the clay to harden, binding the graphite particles together. After firing, the cores are often treated with wax or oil. This step improves writing performance. The wax fills tiny pores in the material, reducing friction when the pencil moves across paper. Without this treatment, the core would feel starchy and inconsistent. Now the two main components are ready. Back at the grooved slats, the assembly process begins. One slat is placed with its grooves facing upward. A thin layer of adhesive is applied across the surface. The glue must be strong enough to hold the structure together, but flexible enough to handle cutting and sharpening later. Graphite rods are then placed into each groove. Machines handle this step in large-scale production, aligning each rod precisely. If a rod sits too high, it could break during shaping. If it sits too low, it might not bond properly with the wood. Once the rods are in place, a second slat is positioned on top. Grooves facing downward. This creates a sandwich, with graphite cores enclosed between two layers of wood. The assembly is pressed together under controlled pressure to ensure even contact and proper adhesion. The glued blocks are then set aside to cure, allowing the adhesive to fully bond the layers. At this point, the structure contains multiple pencils fused together in a single block. The next step is where the familiar shape finally emerges. The block is fed into a shaping machine equipped with cutting blades or milling tools. These tools carve the block into individual pencils while simultaneously shaping their outer form. Most pencils are hexagonal. This shape is not just for looks. The flat sides prevent the pencil from rolling off a desk and provide a better grip. The shaping process must be precise. Each pencil must have consistent dimensions, and the graphite core must remain centered. If the core is off-center, the pencil will sharpen unevenly and may break more easily. After shaping, the pencils are still rough. The surfaces may have tool marks, and the edges can feel sharp. To refine them, the pencils pass through sanding machines. Rotating drums covered in abrasive material smooth the wood and round the edges slightly. The goal is a clean, comfortable surface that feels good in the hand. Next comes finishing. Bare wood is porous and can absorb oils from skin or moisture from the air. To protect it and improve appearance, pencils are coated with paint or varnish. This is done in multiple passes. A typical pencil might receive 6 to 8 coats. After each coat, the pencils pass through drying ovens to cure the finish before the next layer is applied. The color is not just decorative, it can signal brand identity or quality level. The classic yellow finish became popular in the late 19th century as a way to indicate high-quality graphite. Over time, it became a standard look, even though the original reason is no longer widely known. Once the coating is complete, the pencils move to stamping. Here, brand names, logos, and hardness grades are applied using pressure and heat. A foil layer is pressed onto the surface, leaving behind crisp lettering. The alignment must be exact, and the pressure must be controlled so the text is clear without damaging the finish. If the pencil includes an eraser, it goes through another set of steps. A small metal ferrule is placed at one end. This ferrule is usually made of thin aluminum and is crimped tightly onto the wood. The crimping process deforms the metal slightly, locking it in place. An eraser plug is then inserted into the ferrule. Modern erasers are typically made from synthetic rubber or vinyl compounds. They are designed to be firm enough to erase graphite cleanly, but soft enough to wear down instead of tearing the paper. The fit must be secure so the eraser does not fall out during use. With all components in place, the pencils undergo quality control. Samples from each batch are tested. Some are sharpened to ensure how well the wood cuts and how the core behaves. Others are used to write, ensuring the line is consistent with the intended grade. Strength tests may be performed to see how easily the core breaks under pressure. Consider how many variables are involved: moisture content in the wood, ratio of graphite to clay, firing temperature, glue consistency, cutting precision, coating thickness. Each factor influences the final result. A small change in one stage can affect everything that follows. What makes this process stand out is the way it combines natural variation with mechanical precision. Wood is not a uniform material. Each piece has its own grain and density. Yet the process shapes it into consistent, reliable products. Graphite, a simple form of carbon, is engineered into a controlled writing medium through mixing and extrusion and heat. There is also an efficiency built into the system. Instead of making one pencil at a time, the process handles batches. A single slat becomes multiple pencils. A single extrusion produces dozens of cores. Machines are designed to process many units simultaneously, reducing waste and increasing output. Despite all this industrial scale, the basic design remains unchanged. A wooden casing protects a graphite core. That combination has proven to be durable, inexpensive, and effective. It allows for easy sharpening, controlled wear, and a range of writing styles based on core composition. Pick up a pencil and press it to paper. The line that appears is the result of graphite layers shearing off and sticking to the surface. That simple action depends on everything that came before: the drying of the wood, the mixing of the core, the heat of the kiln, the precision of the cutters. It is easy to overlook because the object is so familiar. But the next time you sharpen a pencil and watch the thin curls of wood peel away, consider the path that brought it there.